Draw the shear and movement diagram for each of the member of the frame. Assume the frame has been connected at A and C. Is a roller. Alright, so we have a first of all distributed load. We're going to convert it into a point load. And it's going to be 40K or 40,000 pounds. And then we'll separate each of these members to solve. So we're going to begin with member BC. We're going to have at B, we're going to have both horizontal and vertical reaction forces. And then we're going to have a moment. At C, we're going to have just a vertical because it's a roller. And then we have the point load of 40K. Now to find our reaction forces, let's sum the forces in y direction first of all. And we're going to have positive Cy, positive By, negative 40K equals to 0. We're going to name it equation 1. Then we're going to sum the forces in x direction. And we're going to have Bx equals to 0. And thus we have a solution for Bx. Then we're going to take a moment about the point B. We're going to have moment B. And then we have 40 clockwise. And it's 5 feet away. And then we have Cy counterclockwise 10 feet away. All equals to 0. We're going to name this equation number 2. We can't really do anything right now. So we're going to move over to our next section, AB. So for AB, you're going to have horizontal and vertical force at A. Then we have 2-point load, one 4 feet away from A, and another one is 15K and 4 feet away from 10K. And then we have B. So at B, we have Bx, which we have found to be 0, By, which we don't know, and then we have moment. All right, so let's begin with by summing the forces in x direction to find a solution for Ax. So we're going to have negative Ax, positive 10K, and positive 15K. And we have 0K from the Bx. So for Ax, we're going to have our solution as 25K. And then we're going to sum the forces in y direction. And we're not going to have anything. However, we'll start with our moment before that. So we're going to take a moment about the point. Doesn't really matter A or B. I'm going to do it at A. So we have clockwise 10K, 4 feet away. Then we have clockwise 15K, 8 feet away. And then we have our clockwise moment B, all equals to 0. Solving for moment B, we get our solution as 160 negative 1,000 pounds foot. We can either have it as clockwise on the diagram or we can shift it. Either way, we'll have to use this value. Basically, it says that it's counterclockwise, so to avoid confusion, we should leave it. The reason being because we have already assumed counterclockwise for BC portion and we already have an equation. We'll have to change that if we do that right now. So we'll leave it as it is. Okay, and now we can sum the forces in y direction, but we won't have any solution just yet because we have to go back to our BC section to find a solution for BY. and cy. But looks like we won't have any solution here either because, or we can. Let's do that. We're gonna plug the value of moment b in equation 2. So we're gonna have negative 60, take away 40k times 5, ey times 10 equals to 0. Solving for cy, we get our solution as 36, and then we can plug the value of cy into equation 1. So we're going to have 36 plus by negative 40k equals to 0, and our by is going to be 4k. Alright, so now that we have value of the by, we can plug the value of that into our equation here, and we can get the solution for ay. So let's sum the forces in y direction. So we're going to have positive ay negative 4k equals to 0, and solving for ay we have solution as 4k. Alright, now that we have everything done, we can start plotting for our shear and moment diagrams. Alright, so for shear, we're going to begin with the value of ex, which is positive 25. And then nothing's going to happen for 4 feet. At that point, we're going to get pushed down by 10. So we're going to come down to 15k. And then again, nothing's going to happen for 4 feet. And then we're going to get pushed down 15 feet and we can come down to 0. And we stop here. And this is our portion AB. And now for the next portion, BC, we begin with BY. So our BY is positive 4k. So we're going to go up 4k. I'll do it in red. Let's say this is our 4k. And then from here, we have a distributed load which will take us 40k downward over the course of 10 feet. So let's say this is our 10 feet, and we're going to come down here somewhere, and it's going to be negative 36. Curve is going to be first order curve, and at 36, we're going to get pushed up by cy by 36, and we're going to come up to a 0. Alright, now time for our moment equation, our curve. So for a moment, we're going to begin at 0. Then we have this area, which is positive. So 25 times 4 is 100. So we're going to go up 100 points. It's going to be first order curve. And then we have this area, which is positive again. 15 times 4 is 60. So we're going to go up another 60 points. So it's going to be 160. And then from there, we have this area, because this is a symmetrical area. If we divide our 40 by 10 feet, we know that each jump up or down by 4k results in us moving right or left by 1 foot. And using that explanation, we know that this point is 1 feet away from the current point. So our area under this curve is going to be 4 times 1, which is 4. So our maximum point for the moment curve is going to be this area with 164. And our curve is going to be concaving downwards, second order curve. And then we have this area, which is negative 36 times 9. So we have times half, which is negative 62. And I just realized I didn't times by half when we were calculating our first area here. So it would be 162, not 164. And over the course of 9 feet for our second area, we're going to be concaving downwards and reach the mark 0. And with that 0 curve at the endpoint means that we did our graph correctly. Draw the shear and moment diagrams for each member of the frame. The joint at B is fixed connected. To solve, first, let's find its external action forces. So A is a pin connected. AX is going to be 0, where we have to find, and then C is a roller. Let's take a moment about the point A. We're going to have 6 kilonewton clockwise, 3 meters away. Then we have clockwise 9 kilonewton, 7.5 meters away. And then we have counterclockwise CY 9 meters away, all equals to 0. Solving for CY, we get our solution as 9.5 kilonewton. And now we can sum the forces in y direction to find our solution for AY. We're going to have positive AY, negative 6 kilonewton, negative 9, and positive 9.5, all equals to 0. Solving for AY, we get our solution as 5.5 kilonewton. Alright, so now that we have all the required forces, all that's left to solve is our connection in here, because our shear diagrams will have to be, shear and moment diagram will have to be based on individual sections. Alright, so let's draw its free body diagram. So section AB is going to be like this, where we have AY 5.5 kilonewton, then we have 6 kilonewton concentrated load, and then we'll have BY and BX in a moment. BX we already know is going to be 0. BY we can find by summing the forces in y direction. We're going to have BY as 0.5 kilonewton. And then to find our moment at B, we're going to take a moment about the point B. We could have done it for A as well, it doesn't really matter. And then we have counterclockwise moment B, counterclockwise 6 kilonewton, 3 meters away. And then we have clockwise AY 6 meters away, all equals to 0. And solving for moment B, we get a solution as 15 kilonewton meter. Once we have that, we can plot our section BC. So for our section BC, we can have BY 0.5, and then we have our 9 kilonewton, and we have our CY, which we found to be 9.5 kilonewton. Alright, so now we need to convert these loads perpendicular to the member BC, so that we could draw our shear moment diagrams. To convert our force vectors into vectors perpendicular to the beam, we need to use trigonometry. So our BY is going to be BY prime. So BY prime is 0.5 kilonewton times 3 divided by 5, which gives us negative 0.3 kilonewton. And then our B prime is going to be 9.5 times 3 divided by 5, and this comes up to be 5.7 kilonewton. And then our middle load, which is 9, converting that into 3 divided by 5 is going to be 5.4 kilonewton.